In this video, we're going to be starting to talk about graphing and only talk about how to plot points on the Cartesian plane. So first, a bit of terminology. We can represent ordered pairs of real numbers by points in a plane, which is called the rectangular coordinate system, or the Cartesian plane. Namely, this is named after the French mathematician René Descartes. He only lived from 1596 to 1650, which if you calculate that out, that means that he died when he was about 54 years old. Legend has it that the way that René Descartes, who incidentally is famous for the phrase, "I think, therefore I am," as sort of a starting point for philosophy, the way he realized this was a valuable way of graphing and being able to do different things was that he was tracking a fly on his ceiling, and the moment that he realized that by measuring the distance from each of the two walls to where the fly was on the ceiling, he could accurately place where the fly was. That's exactly how this coordinate system works. First off, though, we form the plane by intersecting two real number lines at a right angle, like so. And the horizontal number line here is called the x-axis. That would be the x-axis. Also, the vertical number line is called the y-axis. And that would be here. A bit more terminology. The point of intersection of the x and y axes is called the origin, which takes place in this picture right here. Also, this divides by drawing the axes. You actually divide by drawing the two axes, you divide the plane into four different quadrants. And here the quadrants are, and I'll go ahead and write this in so you can see it. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Here I use Roman numerals, which is usually the way that they write them. Now, furthermore, each point in the x in the plane corresponds to an ordered pair x, y. So an ordered pair is nothing more than just two real numbers written in this way. And here, these are called the coordinates of the point. The x-coordinate, which, if I was to write it here, would be like this, represents the directed distance from the y-axis. In other words, it measures some distance like this, right? This is x distance away from the y-axis. However, the y-coordinate represents directed distance from the x-axis, like so. So even with all the terminology, this is easier to understand by actually practicing it. So let's go ahead and do an example where we plot the following 5 points. Here, first, let me go ahead and draw my axis. Like so. Now, it's important when you draw your own axes. First, it's helpful to label them in case you get confused between your x and y's. Secondly, it's also important to try to make it at the axes as straight as possible and to try to make the tick marks as well spaced as possible. Also, it helps if you know how your graph, roughly how it's going to look and what points you're going to have. it's tried to draw the graph to be convenient for that. Namely, I see here that I never go further in any direction more than 4, sorry, I don't know where 12 came from, 4, and so here I've made sure and I put 5 just to be safe in both directions. So, that being said, here -1 is our x-coordinate, so we go -1 over on our x-axis, and then we go up by 2. Now, we could go the other way as well. We could have gone up by 2 first and then over by 1. It doesn't really matter. So that would be this point. If we call that A, this would be point A. Let's call this B, C, D, and E. Okay. What about for point B? For point B, we go ahead and we go 3 over on the x-axis, and then 4 up in the positive direction. 1, 2, 3, 4. Okay. So that would be B. What about C? C is easy. That's just the origin. 0 and 0. D, 3, 0. Well, here we go 3 over, but then we don't go up any. So that would be D. That's C there. And then finally for E, we go -2 in the x direction, so over 2. And then we go down 3 because it's negative in the y direction. So right there. And that would be E. There is a notational warning to be aware of here. Namely, what we've noticed is that there is also a bit of a notational overuse here. Namely, the parentheses containing A and B, 2 numbers, that can mean a point or it can mean an open interval. However, usually our context should be pretty clear, okay? And that we'd be saying, oh, it's an interval, either give me an interval or give me a point, and you would understand, oh, that's which one it is in this case. So now let's have you work a problem. Go ahead and plot the following 5 points, and on the count of 3, I'll reveal the solution on a graph. 1, 2, 3. So here are the solutions for each of the different points that I've labeled up there. In practice, it's always good to try to use graph paper when drawing graphs by hand, because that way you can make sure all your tick marks are properly spaced. This may not seem like a big deal right now. It will be when we talk about graphs, because the shape of the graphs can get really messed up if you don't use equal spacing. If you'd like more practice in plotting points and the basics of the rectangular graphing system and coordinate system, be sure to see page 8 of the textbook and work problems number 1, 2, and 5 through 14. In our next video, we'll be talking about 3 very important results: the Pythagorean theorem, the distance formula, and the midpoint formula.